Okay, let's assume we have a question like this. Given two relation tables, we have R1 table. The R1 table has A rows, A is a number, and N columns, N is also a number. Here I need to clarify that A denotes how many tuples we have. It doesn't count as the first row denotes attribute names. It doesn't include this one, right? And for the R1, the A will be equal to 3, right? We have 3 tuples. The N will be equal to 2, right? We have 2 attributes. This is just one example. And let's assume we have another relation table, R2. R2 has B rows and N columns. Then the question will be, what will be the dimensions or size of a new relation R3 equals to R1 times R2? How many rows and how many columns we will have for the R3? And you can pause here if you want to think about this. We will release the answer very soon. I hope you have an answer ready on your papers, right? So according to the definition of relation product, we know that in the output relation for the schema will combine all the attributes from the two input relations, right? If we have R1 with N columns and R2 with M columns, we know by combining them together, we will be able to define a schema for the R3, right? Therefore, by combining them together, we mean we need to sum them together, right? In other words, for the R3, the columns number will be equal to N plus M, right? So this denotes the columns we have for the R3 as the output. Then how about these rows? Remember we mentioned in the output relation, we need to combine all the tuples we have from R1 with R2, right? In other words, for the first record, we combine with this B rows, right? Same for the remaining ones. In other words, for the rows in R3, the number of rows will be equal to what? 2A times B, right? I hope you have a right answer on your paper, right? It will be helpful for you to follow what does this mean for the product. So we see the product, the output relation will be very huge. I mean, the table size will be very big. If we have lots of rows in both two relations, then the A times B will be very big, right? For example, if we have 1 million rows in R1 and 1 million rows in R2, if we calculate the product between them, this number is beyond the limitation allowed for lots of machines. So please be careful. This operation is very expensive. Don't use this very often, especially for large tables. Okay, so this is about the product. And let's come back to the slides. Besides the projection, selection, and the product, we may also want to introduce another operation. It's called renaming. So the renaming doesn't do any changes to the data we have in the database systems. The only change it makes is to the schema. So the renaming doesn't change the relation instances. It can be formally represented as a row and with a subscript as B1 to Bn. This S denotes a new name for the relation. This B1 to Bn denotes a new name for the attributes. And we are working on a relation R as shown here. So you see, this operation will do the changes to the relational schema only. We have an input relation R with A1 to AN as attributes, right? However, right now we plan to make some changes to the names instead. We want to change this R name to S. We want to change A1 to B1, the name, as well as AN name to BN name. So you see the output schema will be different from the input schema, right? Even though they contain the same information. However, the relation has been changed in both the names of the relation as well as the attributes inside the relation, right? So we provide an example about the renaming in the bottom. Let's assume we're still working on the employee table. And for the employee table, we have two attributes, the SSN and the name. However, later on we find that this relation is not very good. and we plan to make some changes to it. And then we can do the changes by using renaming, right? Here we don't want to change the relation name, we only plan to change the attribute name. We can do so by writing the row social security number, comma, first name on the employee relation, right? In this way, we can change the attribute name in the employee relation. We change the SSN to the social security number. We change the name to the first name. Here, different from what we showed before, we do not provide the S here. In other words, we will still keep the employee as a new relation name. The S will be still the employee, right? And we can get a new employee table. We have two attributes. The first one is a social security number. The second one will be the first name, right? And for all the data tuples we have in our original table, they'll all be moved to a new table with no changes at all, right? We still have three data tuples as shown here. So the only change to make here is on the attribute names. And sometimes we can also make some changes to the relation name as well by providing the new relation name before the attributes in the row and the subscript, right? So you can do this by yourself on your papers. This is about the renaming.